Hey, today I'm going to talk to you about the chain rule and when we use the chain rule and why we use it. So the chain rule is a rule that we use and we apply to do differentiation. So we use the chain rule when we are given a function that can be expressed as two simpler functions. In fact, it's called a composite function. So let me give you an example here. Here's an example just on the bottom of my screen. So we've got y equals x plus 3 all squared. Now what we could do is we could break that into two simpler functions by substituting the bracketed part, x plus 3, for something called u. We could say y equals u squared, and then u equals x plus 3. So here's the example just here, where you can look at that. Now the chain rule differentiates each of these two simpler functions together, individually, and then you multiply them together and you get this result here, which is what we call the chain rule. So I've used Leibniz notation here. You can see that to find dy dx of our original function here, y equals x plus 3 all squared, we differentiate y with respect to u first, what's here, alright, then we differentiate u with respect to x here, and then what we do is we multiply the results together, and that we substitute u back in, and we end up with the derivative. So let's just have a go at a couple of these. So up here, you can see I want to differentiate this function. So let's go y equals u squared, and let u equal the x plus 3. Alright, now let's differentiate y with respect to u. We get dy du. Well, dy du is 2u, and du dx is just 1. Multiplying the result of these together and substituting u back in tells us that dy dx equals 2 bracket x plus 3 times the 1, which just is the result. Let's have a look at a second example. As you can see, we've got a function here, y equals 3x plus 4 all to the power 20, and we can break those into two simpler functions. We can say, well, let's let u equal the 3x plus 4, and that means that y equals u to the power 20. So you write the result of those two things down and differentiate each one individually. Well, dy du equals 20u to the 19, and du dx equals 3. Multiplying the result of these together gives you dy dx. So we can say that dy dx equals 20, and we're going to sub u back in, and remember u is the thing we substituted, so we get 3x plus 4. Don't forget we need to raise that to the power 19 and then multiply by 3. Simplifying that gives us 60 bracket 3x plus 4 to the power 19. Now, there's a shorthand method of the chain rule which you can use if you have a good understanding of how we use the chain rule. And the way that works is that you pretty much need to bring the power of the derivative down to the front, as we do when we differentiate. Subtract 1 off the power, and this bracketed part here is our u. So that part is like our new x. Now, if we keep that as it is, reducing the power by 1, we then need to remember to multiply that result by the derivative of what is inside our bracket. Now, let's have a go at doing this using the shorthand. So we go, well, dy dx, so we can instantly go to dy dx. Let's pull that power down, so negative 2. Keep the bracket the same, 4x cubed minus 5x, and reduce 1 off the power there, which is negative 3. Now I need to then extra step multiplied by the derivative of the bracket. So this is going to require some tidying up, obviously. I get 12x squared minus 5. Alright, so that needs a bit of tidying, so let's tidy that one up. We get, let's go negative 2 bracket 12x squared minus 5 is all the numerator, and on the denominator is 4x cubed minus 5x all to the power 3. Okay, now here I've just solidified that relationship, f of g dash, so obviously that's the shorthand of the chain rule. I prefer to write it like this. I just copied that from the textbook. As you can see, what's happening here is there's our function, g x to the power n, and we bring the n down, keep the function the same, reduce 1 off the power, and then multiply by the derivative of the bracket, which I'm calling g dash of x. Alright, and that's pretty much all you need to know about the chain rule.